So before getting into actually transforming integrals, let's look at how to describe some pretty simple regions in polar coordinates, right? In a way that's going to be friendly to double integrals, right? More than saying this is a disk, this is half an annulus, and this is a wedge. You're going to say a little more, all right? So what do we do here? Well, in part A, we have a disk, right? It's a disk of radius 2. So what can the r values go between? Right, so we want to think of these as r comma theta. What can r do here? Well, r can go anywhere from 0 to 2. Right? And what about theta? Well, theta can go all the way around the disk, right? Whatever r value you're at, it can go all the way around. So theta goes from 0 to 2 pi. Right? What about b? B's slightly more complicated. So d, this region, is the set of all r theta. But now, the set of all r theta here, where r, it can actually only get as small as this inside circle, which is of radius 1, and then it goes all the way out to the outside circle, which is radius 2. Right? So we have r is between 1 and 2 this time. Right? Let me put a little hat and base on that one so I distinguish it from this. Right? So r is between 1 and 2. What about theta? Well, so in the disk, you can just say, oh, theta goes all the way around at 0 to 2 pi. When you do thetas here now, you have to remember, theta starts here on the positive x-axis and then rotates counterclockwise. Right? So that means then it starts here on the x-axis in this picture and it can go all the way to the negative x-axis. So in this case, theta goes from 0 to pi. All right? And now we got this last one down here. Well, how do we describe that? Well, let's start by looking at r again. And you could start by looking at either one. You don't have to start with r. But typically, we'll find that things tend to start with r. We'll give some that are not, but anyway. So here, and remember, when you're thinking of r in polar coordinates, r starts at the origin and makes its way out along rays coming out of the origin. So here, r starts at 0 and can go all the way out to 3. Right? So r is between 0 and 3. What about theta this time? Well, theta can start on this line y equals x, and it ends on the y-axis. So how do we describe those theta bounds? Well, it's a matter of remembering what angles these are, or figuring out what angles these are. Right? Well, this is the exact diagonal line here. So this angle is pi over 4, right? The angle of inclination of y equals x is pi over 4. So theta starts at pi over 4 here, and then it goes to the y-axis, which is pi over 2. Right? So notice that each of these regions here is given by, in polar coordinates, just a rectangle. Right? So there's one more region we're going to describe in polar coordinates, which is a rectangle. It's the most general one. Right? And then we'll get on to switching the double integral. So we'll do that next.